Question 14. The distance time graph shows information about part of a car journey. So here is the distance travelled in meters and the time in seconds. Use the graph to estimate the speed of the car at time 5 seconds. So here's 5 seconds. That's going to be the distance travelled. And a piece of knowledge that you need to answer this question is that the gradient of the curve here at 5 seconds is the speed of the car. We don't know how to work out the gradient of a curve at the moment, but the best way of approaching it is to draw a tangent, a straight line that's just brushing the point that we need. So we need the speed at 5 seconds. My tangent here just touches the curve at 5 seconds, but it keeps going. And the gradient of this line, the blue tangent I have drawn, represents the gradient at time is 5, which represents the speed. So we know to work out the gradient of a line that I need two coordinates. So I've got this one down here. My two coordinates are here and here. So my two coordinates are 3, 0 and 8, 70. To work out the gradient, we normally use the letter m. It's the difference in the y-axis, so how much has it come up, which is 70 meters. It's 70 there. Divided by how far along have I come. So from 3 seconds to 8 seconds is 5 seconds. We don't always put the units in for the gradient of a line. Here we do, because I know the speed is going to be in meters per second. 70 divided by 5 is 14. There is a range of values that they would accept, and given that you'll get slightly different values when you put your tangent in, but we have 14 meters per second. For drawing the tangent, you would get 1 mark, second mark for getting to the right sum, and the third mark for doing it correctly.